Hello everybody and welcome to yet another math video. In this video, I'll be going over optimization application exercises, and with that we will be solving those using the simplex method, as you can see here. And this set of videos, this one and the next one, will be corresponding to the notes for assignment 21 in ABS if you are in that course. All right. So here we have a word problem, and this is just like the simplex method, except you'll notice you don't have a maximize function, you don't have a system of inequalities, and you have to create that before you go through and work through the simplex process. So let's read. A small company manufactures two different types of computers, a desktop and a laptop. A single standard computer desktop costs $400 to make and takes 40 hours of labor. The portable laptop costs $250 to make and 30 labor hours to produce. The company has $20,000 available to make computers and 2,160 total hours to make the computers. The profit on the standard laptop is this much, aka the desktop, and the laptop is, the profit is $220. Find the number of desktops and laptops to sell in order to maximize profit, and there's a lot there. It took me almost an entire minute to read that. What are you supposed to do first? Well, the first thing you should do is write down your variables. And usually we're using x sub 1 and x sub 2. What are we trying to find out? Well, we're trying to figure out the number of desktops and laptops to sell in order to maximize profit. So we can call x1 the number of desktops and x2 the number of laptops. All right, from there, so you want to do your variable definitions first. I think the second thing you want to do is write down your maximization equation, and it's usually in that same sentence or nearby what variables are. We're trying to maximize profit. That is the word right there, maximize the profit. So we want profit to be what? Where else do you see information about the profit? It's right here. The profit for a desktop is 320. So that's going to start the equation. $320 for each desktop. I may have misspoken myself. I apologize. The profit for each laptop is 220. So there is the objective function. Then we have some inequalities to make. So I'm going to do that over here, the inequalities. Well, I mean, we'll get this out of the way. X sub 1 and X sub 2 both have to be bigger than or equal to 0. No problems. Then what you have to do from there is continue reading to see what other information you know about X sub 1 and X sub 2. So what we know about these computers is how much they cost to make, and we have that value for each of them, and how long it takes to make them. So we can have a labor inequality. Say it would take 40 hours for each desktop, so 40 times x sub 1 plus 30 hours for each laptop, and that will be less than or equal to the total number of hours available, which would be 2,160 hours. So basically we found all of the hours, 40 hours for a desktop, 30 hours for a laptop. There's the total number of hours. And when they say the company can provide 2,160 total labor hours, that means you can work right up until that point, but you cannot work more than that. That's why we're using a less than or equal to here. The other inequality will deal with the money. You say they have $20,000 of capital. That means available money to spend to make these computers. Laptops cost 250, desktops cost 400. So we will use that information for the second inequality. 250x sub 2 has to be less than or equal to $20,000. All right, well, now that we have everything, we can go through and change the inequalities that we have. We don't need to change these, but we need to create the E system. And I'm going to do that with blue ink here. Or we'll just do this. So the E system would look like, from this first equation, 40x sub 1 plus 30x sub 2 plus slack variable 1 equals 2160. This equation for the red one would look like 400x sub 1 plus 250x sub 2 plus slack 2, 20,000. And then over here with the maximize equation, the profit equation, remember P has to remain positive. And so we'd have negative 320x sub 1 minus 220x sub 2 plus P equals 0. And from here, we can just go ahead and set up the Simplex Tableau, the matrix. So again, we always want to start with the S sub 1 equation first. So we'll have a matrix here with a column x sub 1, x sub 2, s sub 1, s sub 2, p. And the equation here is 40x sub 1s, 30x sub 2s, 1 s sub 1, 0, 0, 2160. The red equation here, 400 x sub 1, 250 x sub 2, 0, 1, 0, 20,000. The last one here was the profit equation. We had to do negative 320 x sub 1, negative 220, 0, 0, 1, 0. And there's the Simplex Tableau. From here, I'm going to slowly release some steps, and I'll probably have to shift up here before I do that. So let me do that. That's basically the rest of the page that I have to work with there. So I'll slowly, about every 6 or 7 seconds, release the rest of the work for this question, and I will go over it at the end. And this is the last step that I will be able to get for this particular page. I'm going to have to continue this on the next slide, but let me go through it really quickly here. The first thing I did was I found the pivot column based on the most negative number between all of the negative numbers in the bottom row. So I knew this was my pivot column. From there, I had to take every element in the last column and divide it by the element in the same row. So I took 2,160 divided by 40, got 54. Then I took 20,000 and divided it by 400 and got 50. When you do these divisions, you don't do the divisions on the bottom row at all. And you pick the smallest number here that is not negative. Well, they're both not negative, so we just have to pick the smallest number here. 50. That's what led me to find this being the pivot position. And right away, you can go straight up and say x1 will enter and s2 will exit. This will exit, which means this variable will disappear in later steps and it will be replaced with x sub 1. How do we get to that point? Well, first there needs to be a 1 here. You can divide this row by 400, which gives you this row here. Then you can replace S2 here with this row. And from there you get zeros above and below by following these steps, and you'll end up with this matrix. On the next slide, I will have this matrix and we can continue the exercise. But before we go to the next slide, I want to make a quick adjustment. I realize now that this should be a positive 4/5 as I have over here. So that will make a big deal when we get over to the next slide. All right, so here we go. We have this going on, this matrix from the previous slide. And every time you have an entering variable, a new variable show up over here on the left, we've got to just go back and take a look at the bottom row. Are there any other negative numbers here? I mean, clearly, yes, there's a negative 20. So this means we get to start the process all over again. We have to, I'm starting with a pivot. We have to find the pivot value here in this column. So how do you do that? You come off to the left and do your divisions again. So here we'll have 160 divided by 5. And here we'll have 50 divided by 5/8. Ooh, I don't want to do that. Let's not divide by a fraction. Let's multiply by the reciprocal of that fraction. So get rid of this. There we go. So it won't be 50 divided by 5/8. It'll be 50 times 8/5. So instead of dividing by a fraction, we multiply by its reciprocal. So when you go through and divide 160 by 5, you'll get 32. And when you multiply this, which is really division by 5/8, you'll get 80. Right? The 10 and the 5 reduce, or sorry, the 50 and the 5 reduce away, leaving you with a 10. 10 times 8 is 80. So what that means is the pivot position over here is going to be this top row, because that is where the smaller number was. From there, you need to make sure we get a 1 in that row. So that would be S sub 1 divided by 5 would replace S sub 1 again. Then, what would that look like? It would look like 0, 1, 1/5. So again here, instead of dividing by 5, you can think of this as multiplication by 1/5, because we do have a fraction here that we need to work with. So we can multiply the numerators together. 1 times -1 is -1. And in the denominators, 5 times 10 is 50. And we're back to 0, and 160 divided by 5 we figured out right over here. So that is just going to be 32 to round out that row. You can rewrite the new matrix. Here's that matrix. And from here we need to get zeros underneath this one here. I guess I should have said, and I'll say it now, x2 will be the entering variable, and variables only ever enter or exit from the left side again. So x2 will enter here and s1 will exit. So from there we need to take, let's see, it'll be s sub 1, but we have to multiply it by -5/8. S sub 1 plus x sub 1, that's the row, and we will replace x sub 1. And over here in a different color, I'm going to say, let's see, 20 s sub 1 plus p will be the new row p. And try these row operations, pause the video, I'll be back in a few seconds with what they look like. All right, here are the row operations. There's a whole lot of fun going on here. I will have one more slide coming up in a few seconds with these rows in this matrix. Ignore this negative sign here. This is not necessary. and we'll get to a final answer on the next slide. All right, final slide. Let's take a look here. We have the S sub 1 variable that exited because that's where our pivot position was the second time around. The X sub 2 variable entered, and now we don't have any more negatives in the bottom row. We can just read off our answer. X sub 1 will be 30, X sub 2 will be 32, and the profit maximized will be at $16,640. Now, since we were given a story, we have to actually use some English writing here, write out a whole sentence. Writing in math, it's not a big deal. It can be a very simple sentence. We have to go back and remember what X sub 1 and X sub 2 mean. Luckily, you do not have to go back to the beginning of the video to find it. So I'll remind you here, X sub 1 was the number of desktops, and X sub 2 was the number of laptops. And you can create a very easy sentence every single time. You can say the maximum profit of $16,640, and make sure you're using your units. In this case, this dollar sign will happen by selling 32, let's see, those are laptops, and 30 desktops. Easy. So there is the final answer. And you can come back up and check this out in the matrix here. The profit down here is going to be maximized at $16,640. X sub 1 is 30, which we have. That would be 30 desktops. X sub 2 is 32. Hooray! And that is laptops. Fantastic, everybody. It's a long video for one example, but you'll see exactly how everything works together all at once. So I hope this made sense. I've got nothing else for you for this example. Be ready for a video just on the setup of this, and good luck.